Hi class, this is our fourth hour for chapter 7 Haloalkane. So in this hour, we are going to look further into the chemical properties of haloalkane. So in this video, we are going to learn how to use Grignard reagents to produce different products. First of all, you need to understand that from haloalkane, you can prepare our Grignard reagent. So I use a general formula Rx to represent haloalkane. So when you react the haloalkane with magnesium in dry ether solvent, you are going to get your Grignard reagent. So before this, we know that in our haloalkane, we have a delta positive carbon in our alkyl group and a delta negative halogen. So when you react with magnesium in dry ether, you are generating a nucleophilic site inside Grignard reagent. So this carbon inside our alkyl group become partially negative. Okay, because we inserting the magnesium atom between our alkyl group and the halogens. Okay, so the carbon in Grignard reagents is the nucleophilic site. Okay, so in this case, we are referring to this carbon here. So the reactions for Grignard reagent, if we react it with water, you are going to create alkane. If you react Grignard reagent with methanol, followed by hydrolysis process, you are going to get your primary alcohol. So in this case, the alkyl group from our Grignard reagents combined with methanol will give you CH2OH. Next, if you react the Grignard reagent with aldehyde followed by hydrolysis, you are going to get a secondary alcohol. So in this case, it depends on what is the structure of our aldehyde. But remember, we must check the class of the product produced. Same things go to when you react Grignard reagent with ketone followed by hydrolysis. You're going to create or produce a tertiary alcohol. So it depends on what is the structure for our ketone. And last one, if you react the Grignard reagent with carbon dioxide followed by hydrolysis, you are going to produce carboxylic acid. Alright, say we have the haloalkane here. This is our delta positive carbon and delta negative halogen. So when you react with magnesium in dry ether, the solvent, you are creating a delta negative carbon, your nucleophilic site in Grignard reagent. Okay, and a magnesium bearing with partially positive charge. So when Grignard reagent react with water, you are going to produce alkane. So please bear in mind, if you are using condensed structure, please check the number of hydrogens. So from here, we have only our CH group. If we are producing alkane, it becomes CH3, CH2, CH3. Next, if you react your Grignard reagent with methanol followed by hydrolysis, so in methanol, there is a delta positive carbon and delta negative oxygen. So the new bonding will form between the delta negative carbon in Grignard and the delta positive carbon in methanol group. Okay, so in this case, Grignard with methanol followed by hydrolysis, generating primary alcohol. And when Grignard reagent react with aldehyde beside methanol, so say in this case we have our propanol, okay, the aldehyde with 3 carbon. So in this case, again we are going to combine between these 2 carbon, the delta negative carbon in Grignard and the delta positive carbon in our aldehyde. Okay, so this is the carbon. So the new bonding form here will be the alkyl group from Grignard combined with the carbon, the delta positive carbon in our aldehyde. So it becomes CH, CH2, CH3. The one that combined with your double bond O become OH group. Okay, so in this case, the carbons that bear with your OH group contain 2 carbon neighbor, and this is our secondary alcohol. Next, Grignard reagent with ketone. Okay, in this case, we have our propanol, a ketone with 3 carbon followed by hydrolysis. So we are combining between these 2 carbons and the new product form, it looks like this. So exactly the same structure as in our ketone, okay? But the C double bond O break to form and OH. And last but not least, Grignard with carbon dioxide followed by hydrolysis to generate our carboxylic acid, COOH. Alright, so another example for you, if we have a chlorocyclopentane react with magnesium in dry ether, so you are creating Grignard reagent, you just insert the magnesium between the carbon and the Cl. Okay, so in this case, this is our delta negative carbon and a delta positive magnesium. So when this Grignard reagent react with water, you are producing a cyclopentane. And when Grignard react with methanol, followed by hydrolysis, okay, remember there is a cyclopentane, 5 carbon initially. Okay, so methanol, there's 1 carbon, so we are going to form a CH2OH. Okay, which means if you can do your simple calculation, 5 carbon in our Grignard, 1 carbon in methanol, so in our final product there will be 5 plus 1. So if you got a Grignard react with the aldehyde, so in this aldehyde we have 1, 2, 3, 4 carbon in total. Okay, and please remember to identify our delta positive carbon site, our electrophilic site. So in this case, you are going to combine the delta negative carbon in Grignard and the delta positive carbon in the aldehyde. So the new bonding formed between the delta negative carbon in Grignard and the delta positive in the aldehyde. Okay, so this carbon bearing the oxygen, from double bond it becomes single bond and the O become OH. And then the remaining of your alkyl group will just continue exactly the same. Okay, so you do a simple calculation, 5 carbon in Grignard, 4 carbon in aldehyde. So in total, we should have 9 carbon, 5, 6, 7, 8, 9. So this is our secondary alcohol. Grignard react with ketone. In this ketone, we have 4 carbon. Okay, so the same thing, we still need to calculate the number of carbon. Okay, so new bonding formed between delta negative carbon in Grignard and the delta positive carbon in ketone. Okay, so new bonding form over here, we have the carbon bearing with oxygen, and after hydrolysis, it will generating the OH group. And then continue with the remaining of your bonding. Don't forget, at this carbon, still we have another methyl group. So if you calculate back, 5 carbon from the Grignard, 4 carbon from the ketone. Alright, and our last structure, Grignard react with carbon dioxide followed by hydrolysis to generate a carboxylic acid. So let's move into our 4th-hour tutorial questions. Okay, so for this first questions, Grignard reagent is an example of organometallic compound which is very useful in the synthesis of many organic compounds. Shows the preparations of a Grignard reagents from bromoethane, this one, and chlorobenzene. Alright, so from bromoethane, when they react with magnesium in dry ether solvent, so you're going to create your Grignard reagent. So between the carbon and the halogen, insert your magnesium. Okay, so this is our Grignard reagents. Don't forget to practice writing down your delta negative carbon and the delta positive magnesium. And the next one, we have our chlorobenzene when you react with magnesium and dry ether solvent. So the magnesium insert between the carbon and the Cl group. Don't forget to label your delta negative carbon and your delta positive magnesium. Alright class, so let's continue with our second questions. Draw the structure formula of H to L. So for A, we have our Grignard reagent. So there is 4 carbon for our Grignard reagent. So let us label the delta negative nucleophilic site of the Grignard reagent. Okay, and the delta positive magnesium. So the Grignard reagent react with methanol in ether as a solvent in our first step, followed by hydrolysis. Okay, so there is a delta positive, the electrophilic site in our methanol. Okay, so remember this CH2O is the structure of methanol, which look like this. Okay, so we have our delta positive carbon. Alright, so the new bonding will form between the delta negative carbon in Grignard with the delta positive carbon in our methanol. Okay, so we have the new bonding form between this carbon with our CH2O. Okay, from C double bond O becomes C single bond OH after the process of hydrolysis. So reactions between Grignard and methanol followed by hydrolysis produce our primary alcohol. For B, you have MgCl directly attached with the benzene ring. Therefore, we can identify our nucleophilic carbon, the delta negative carbon. Okay, so in our first step, reactions between Grignard with our ethanol in ether solvent, followed by hydrolysis. Okay, so there is a delta positive, the electrophilic side carbon in our ethanol. Therefore, the new bonding form between the delta negative carbon with the delta positive carbon. So we are forming a new carbon-carbon bonding between the benzene with the ethanol. So CH, CH3. Okay, at the CH here, we have a double bond O initially, which then it will break into single bond and after hydrolysis to produce a secondary alcohol. And next one, we have a Grignard reagent. So remember to label our delta negative carbon and the delta positive magnesium. And it reacts with ketone in ether solvent in our first step, followed by hydrolysis. So the ketone as well we have a delta positive carbon, delta negative oxygen. So the reactions happens between the nucleophilic carbon in Grignard with the electrophilic carbon in ketone. Okay, so there will be a new bonding formed between these two carbon. Okay, so I draw out the structure of my Grignard reagent, followed by the carbon double bond O, this electrophilic carbon, which we have the carbon double bond O break into single bond, and after hydrolysis to produce an OH, and then another two CH3 group. So if you can see over here, the carbon which bear with an OH group is actually come from our ketone, whereas the one that are highlighted in green box is come from our Grignard reagent. So the new bonding form between these two carbon. Okay, carbon number 2 and carbon number 3. For questions D, this is a reaction between haloalkane with our sodium hydroxide. So remember in the skeletal structure, this is your carbon number 1, 2, and 3. Okay, Cl as our leaving group, which is substituted by our strong nucleophile, the OH minus. So our final product for K, the Cl is substituted with an OH group. For E, we have a Grignard reagent react with carbon dioxide in the first step, and then followed by hydrolysis. So this is our delta negative carbon, delta positive magnesium. And in our carbon dioxide, remember the structure for our carbon dioxide look like this. Okay, so we still have our delta positive carbon, the electrophilic site, and the delta negative oxygen. Okay, so in this case, the new bondings formed between the delta negative carbon in Grignard with the delta positive carbon in carbon dioxide. Okay, so the new bondings formed between the delta negative carbon with the carbon dioxide, followed by hydrolysis to create your carboxylic acid.